Hi, good evening. I'm Harsh and I'm from Tinydancer. And today I'll be talking about like AF-XDP receiving side on Agave. Why do we need an AF-XDP? Oh, okay. Low latency receiver at the kernel using AF-XDP. So AF-XDP is basically like a Linux API that allows the applications to receive packets very quickly from the network interface card. So it's like bypassing all the kernel level overhead, and you can just like blazingly fast receive packets. Why do we need why do we need to skip the kernel path? There's a lot of reasons. So I'll walk you through that. Here's the regular kernel packet flow. As you can see, the packets flow from the wire to the NIC to the DMA, SKB. There's a lot of these individual boxes are like individual stages that the packets flow through per packet. Here's the TLDR. There's a lot of allocations, syscalls, and the kernel path adds a lot of layers, and it's very inefficient. So that's why we need like something new, and we have AF-XDP for that. So AF-XDP is basically uh, a faster receiver socket that you can use for Solana validators, because Solana validators accept packets and transactions very quickly, like millions of transactions per second, and every microsecond counts. There are three components to AF-XDP receiver. One is the AF-XDP program, which attaches to the network interface card, and you can just direct packets to wherever we need. There are like software ring buffers, which are like low level ring buffers that you can manage in the user space without any overheads. And there's a big reservoir that's called user space memory, which is like used to allocate the buffers and recycle buffers from. Here's the whole AF-XDP packet flow that you can like quickly go through. The packets flow from the RX queue to the XDP program, where we redirect to our socket of choice. And then there are two modes with our copy and zero copy, but they are still low overhead than the kernel path. Here's the big diagram of how packets flow through rings. So the user space allocates fill rings. Fill rings are basically like a temporary memory that you can allocate, give to the kernel, to the packet, to fill the packet from the queue. As you can see, like there are two modes. There's a copy mode. There's a zero copy mode. The zero copy mode is the fastest mode that you can do. Agave is the Solana client, as you know, but Agave didn't have a faster receiving packet system, so I built it, and I'll be demoing it now. So here's my setup. There are two boxes. One is the transmitting side, which transmits millions of packets per second, which is the server A, and it blasts like 1 million packets per 64 burst rate. And there's the receiving side, which has our XDP receiver, and here's the driver, and here's all the other low level details. There's a lot of configurations. So yeah, right. This is my IKVM console. Oh, okay, it's not able to connect. Anyways, I'll show you a quick demo of the video that I've shot. Okay. So as you can see, this is my AF-XDP receiver binary, and you can see the flags. I'm selecting a QID S3, which is the actual physical network interface card QID, and I'm uh, looking at the mode here, which is zero copy, which is the copy mode that I'm using, and I'm selecting CPU 7, as you can see there, and as I play, this is the CPU 7, and this is the actual kernel trace logs that you can see, which monitors the kernel level packet, and you can see the logs where the packet is going, and where the queues are, and which CPU it's using. And this is me setting up the CPU, the pinning the CPU to the receiver so that you get the highest possible performance. And this is my blaster, which is the transmission side. And as I blast packets, I receive millions of packets. As I stop it, you'll see when I stop it. Uh, and this is how I get the packets from the transmission to the receiver side, and it's all like zero allocation, zero syscalls. So it's pretty fast. And it's not in Agave yet. I'll be publishing it to Agave very soon. I'm in talk with Alessandro, and hopefully I get my PR approved. And yeah, as you can see, the line rate. So yeah, that's basically my demo. Okay, so here's my high level setup that you can replicate. If you want to reach out to me, you can reach out. Here's the whole overview of the packet flow, and we just set the RSS steering XDP program invoke, and it all the packets are like managed inside the user space. There's no kernel here. This is the redirect program that I built, which is attached to the network interface card. And so what's next? I'll be optimizing the ring buffer management. So that's where I lag right now. There's a lot of packet drops that I do. There's multiple strategies that you can employ to manage how packets flow through the rings. So that's where the optimization is also there. And the zero copy mode, unfortunately, we couldn't demo it, but the zero copy mode works really well. But then there's still a lot of jitter that I need to remove. And there's some of my like I have to integrate this with some of my personal projects. So one is the shred stream, Gito shred stream, where I'll get access to packets very super low latency, and I can be ahead of all the traders basically, and minimize XDP redirect errors, getting it pushed to Agave upstream. There will be a detailed blog post series from me, and yeah, hopefully open sourcing it soon once Alessandro approves it. So yeah, thank you.